Okay, our next lesson is on greatest common factor. This is lesson 2. And you can see my spooky theme. But basically, we'll be looking at two or more number expressions, meaning basically numbers with variables, to see what the largest factor they have in common is. So we're looking to see, like if we were looking at the first example, 75 and 60, we want to think about what numbers go into those numbers. And then we want to figure out, well, what's the biggest one that they have in common? Again, you've done this before, and some people can just look at it and they can think about it and get the answer. But it starts to get a little more complicated when you add variables to it. So I'm going to show you what I think is a good method. However, if you have another method that seems to work, then by all means use it. Okay, so I have 75 and 60, and I'm not really sure what they have in common. I could list all their factors and look to see what the biggest one is. Or I could break both of those numbers down into their most basic components, and I could compare. So I'm going to do that. I'm going to prime factorize each of those numbers. I also kind of like prime factoring. So here we go. So for the prime factorization of 75, I get 3 times 5 squared. For the prime factorization of 60, I get 2 squared times 3 times 5. Now, when I'm looking at both of these numbers in their most basic form, I can see what they're made up of. So I want to know, okay, well, if this is what they're made up of, then what do they have in common? What goes into both of these numbers? So if I look at the 2's, I can see that this one has 2's, but this one does not. So I can't put any 2's in common, but they do have a factor of 3 in common. So here I'm going to write GCF equals, and I know they have 1, 3 in common, so I write that 3 down. Then I look at the 5's, and I say, do they have any 5's in common? And in fact, they do. They have this 5 in common, and this one has 2 5's because it's 5 times 5. So in common, they only have 1. So my GCF would be 3 times 5. But I don't want you to express GCF like 3 times 5. I actually want you to come up with what that is, which in this case is pretty easy, 15. Sometimes it's a little bit more difficult. So 15 is the greatest common factor of 75 and 60. Okay, so let's go down to the next problem. Now I have 75 and 32. So 75 and 32 are going to be a little bit different. So 75, I already came up with the prime factorization. It was 3 times 5 squared, because I found that above. I know it's not there anymore. But when I do 32, I'm going to multiply this one out and figure out what it is. 16 times 2, 8 times 2, 4 times 2, 2 times 2. So the prime factorization of 32 is 2 to the 5th power. Just 2's. So when I look to see what these two have in common, 75 is 3 times 5 squared, 32 is 2 to the 5th, so they actually don't have anything in common. So what would you write? You would write 1, because 1 goes into both of these numbers. The GCF in this case is 1. So neither one of these numbers is prime. They have a bunch of factors. They just don't happen to have any in common. So when you have two numbers that don't have anything in common, they are actually called relatively prime, as you can see in this definition. So relatively prime are two numbers with a GCF of 1. The only factor they have in common is 1. So that's a vocabulary word that will come up in the lesson, and then I'm sure you'll put it in your notes to self at a later time. Okay, so now I'm going to take you one step further, and we're going to come up with a problem that has variables in it. So if I have, 60x squared y, and I have 99xy to the 3rd, and I want to see what those two have in common as far as a GCF. Well, the first thing I'm going to do is do their prime factorization. So, there we go. 6 times 10, 3 times 2. Don't you just love prime factoring? 2 times 5. I just do the number portion and I come up with 2 squared times 3 times 5. And I can't forget my variables, times x squared times y. Then I'm going to do 99, and 99 is 9 times 11. 11 is prime. 3 times 3. So I get 3 squared times 11 times x times y to the third. So now I'm going to go ahead and look for the GCF. So I want to know, what do these two have in common? I need a little bit more space. Oh no. Here we go. Okay, so what do these two have in common? So what they have in common is they both have a factor of 3, but they don't have anything else in common as far as the numbers go. But in the variables, they do. They actually both have an x. This one over here has 2 x's. This one over here has 1 x. So in common, let's write it down here. They have a 3. They have 1 x. And how many y's do you think they have in common? Think about it. They have 1, because this one has 1 y, this one has 3 y's, and so in common they have 1. So the GCF of these two numbers with variables would be 3xy, and that's finding GCF.